For months, unusual metal structures welded onto Russian tanks and armored vehicles have attracted the attention of military analysts and observers of the war in Ukraine. These metal grids, often mounted above the turret and hull of armored vehicles, have been widely described by Western experts as improvised anti-drone protection. Informally labeled cope cages, the structures were intended to counter one of the most disruptive technologies on the modern battlefield: small attack drones carrying explosive charges. The concept behind the cages was relatively simple. By placing a metal barrier above the vehicle, Russian forces hoped that explosive devices dropped from drones would detonate prematurely when striking the cage instead of the armor beneath it. However, footage and battlefield reports collected over the past months increasingly suggest that these improvised defenses have failed to deliver the protection that Russian forces expected. The widespread use of such cages reflects the growing pressure that drone warfare has placed on armored units. Since the beginning of the full-scale invasion of Ukraine in 2022, unmanned aerial systems have become a decisive factor in combat operations. Ukrainian forces have relied heavily on first-person view drones, loitering munitions, and heavier strike drones to attack vehicles, artillery positions, and infrastructure. In response, Russian units began modifying their equipment with additional protective structures, hoping to adapt quickly to the evolving threat. Yet analysts say the results have been mixed at best. High-precision drone strikes, especially those approaching from steep angles above the vehicle, can bypass or penetrate these cages with relative ease. In numerous recorded strikes, drones either detonate directly within the cage structure or maneuver through gaps to strike the vehicle's vulnerable upper armor. The scale of armored losses in the war highlights the severity of the problem. Open-source monitoring groups estimate that Russia has lost more than 4,000 tanks since the beginning of the conflict. While not all of these losses can be attributed directly to drone attacks, unmanned systems have become one of the most efficient methods for disabling armored vehicles on the battlefield. The improvised cages therefore emerged as a rapid, low-cost attempt to mitigate the threat. Nevertheless, as new footage continues to circulate online, many of these vehicles are shown being destroyed despite the added metal protection. The images have reinforced the view among defense observers that the cages provide limited practical benefit against modern precision strikes. The reliance on improvised defenses has extended beyond armored vehicles. Similar protective concepts have appeared in other areas of Russian military infrastructure. In several locations, large industrial facilities and strategic energy sites have been covered with net-like barriers intended to intercept incoming drones. Satellite imagery released by the United States-based space intelligence company Vantor in December 2025 showed extensive netting stretched above multiple fuel storage tanks at an energy facility in Russia's Pskov region. According to analysts who reviewed the imagery, 15 large fuel tanks belonging to the Pskov Nefa product company were partially covered with large mesh structures designed to prevent drones from striking the tanks directly. The facility near the city of Velikiye Luki, located roughly 500 kilometers from the Ukrainian border, later became the focus of international attention. On the night of February 19, 2026, Ukrainian drones reportedly targeted the site despite the protective netting. The attack was carried out using multiple unmanned aerial vehicles operating in coordination. According to Ukrainian sources, swarm tactics were used in an attempt to overwhelm the defensive measures surrounding the fuel depot. Drones approaching the facility reportedly broke through the net barriers and struck the storage tanks, igniting a large fire that burned through significant quantities of fuel. Video footage and images shared after the strike showed flames rising above the facility, illuminating the surrounding area. The incident quickly became a symbol of the broader challenges facing Russia's defensive strategy against long-range drone operations. Military analysts say the attack demonstrated that static protective measures such as nets or cages may slow or deflect certain types of drones, but cannot reliably stop determined strikes conducted with multiple aircraft. As Ukraine has expanded its long-range drone capabilities, Russian authorities have increasingly attempted to shield critical infrastructure using both traditional air defense systems and improvised physical barriers. However, the Velikiye Luki attack suggested that even facilities located deep inside Russian territory remain vulnerable. The use of such protective systems reflects the growing importance of energy infrastructure in the strategic dimension of the war. Oil depots, refineries, and fuel storage facilities play a crucial role in sustaining military operations and generating revenue for the Russian state. Repeated attacks on these sites have therefore become a central component of Ukraine's long-range strike strategy. Throughout 2025 and into early 2026, Ukrainian drones targeted multiple refineries and energy installations across Russia, forcing temporary shutdowns and damaging processing capacity. According to defense assessments cited in Western intelligence briefings, more than 70 attacks on Russian territory during 2025 affected between 17 and 38% of the country's refining capacity at various points. The events surrounding the Velikiye Luki fuel depot illustrate how this evolving battlefield dynamic has pushed both sides to experiment with new forms of defense and countermeasure. For Russia, the rapid construction of cage structures, net barriers, and other physical obstacles reflects an attempt to quickly adapt to the persistent drone threat. Yet, as drone technology continues to evolve, the effectiveness of these methods remains under scrutiny. The burning fuel tanks in the Pskov region served as a dramatic reminder that even extensive protective measures may not prevent determined aerial attacks. Against this backdrop, the conflict has increasingly become a contest of adaptation. Each side is attempting to counter the other's innovations while protecting its own critical assets. The spread of improvised defensive systems across Russian military equipment and infrastructure illustrates the urgency of that effort. At the same time, the events in Western Russia demonstrate the continuing vulnerability of fixed targets in an era where relatively small unmanned aircraft can travel hundreds of kilometers and strike strategic facilities with precision. The attack on the fuel storage facility in the Pskov region became one of several incidents that have intensified scrutiny of Russia's defensive approach against drone warfare. According to information cited in military reporting and intelligence updates, Ukrainian strike drones approached the Velikiye Luki fuel depot in coordinated waves during the night of February 19, 2026. The drones targeted fuel tanks belonging to the Pskov Nefa product company, which had been partially covered by large mesh structures intended to intercept or disable incoming unmanned aircraft. Despite these preparations, the drones penetrated the net barriers and detonated directly on the storage tanks. The resulting explosions ignited large volumes of fuel and created a fire visible across the surrounding area. Satellite imagery released earlier had already drawn attention to the unusual protection method used at the facility. Images captured in December 2025 by the United States-based space intelligence firm Vantor showed 15 large cylindrical tanks covered with wide net structures stretched above the installations. Analysts suggested the nets were designed to interfere with drones descending from above, either by entangling their propellers or triggering premature detonation of explosives. However, the February attack demonstrated that drones moving at high speed were able to pass through or tear apart the mesh before reaching their targets. Ukrainian sources said swarm tactics were deliberately used to overwhelm the protective measures and ensure that at least some drones reached the tanks. The incident was part of a broader pattern of Ukrainian long-range strikes targeting Russia's energy infrastructure. Military analysts report that refineries, oil depots, and storage facilities have increasingly become focal points of Ukrainian operations aimed at reducing the financial and logistical resources available to Moscow. According to estimates referenced in Western defense assessments, more than 70 drone attacks were carried out against Russian territory during 2025. These operations affected a significant portion of the country's refining capacity, temporarily disrupting between 17 and 38% of output at different points during the year. Damage to energy facilities forced Russian authorities to impose temporary export restrictions on fuel products in order to stabilize domestic supply. The pressure on the energy sector continued into 2026. From January through the end of February, several additional strikes targeted major refineries across Russian territory. One of the most significant incidents occurred shortly before the Velikiye Luki attack. Between February 11th and 12th, Ukrainian drones struck a refinery located on the western bank of the Volga River. The facility, operated by the company Lukoil, is among the largest in Russia, with an annual processing capacity estimated at 13.5 million tons. The strike marked the 9th time the refinery had been targeted since the beginning of the war in 2022. According to analysts reviewing the attack, the incident raised further questions about the effectiveness of Russia's layered air defense systems protecting critical infrastructure. Russian forces have deployed a range of surface-to-air missile systems, radar networks, and electronic warfare units around key industrial facilities. However, Ukrainian drones have repeatedly managed to penetrate these defenses. Experts note that the relatively small radar signature and low flight altitude of many drones can complicate detection, especially when multiple aircraft approach simultaneously from different directions. In several cases, drones have reportedly slipped through defensive gaps and struck facilities despite the presence of modern air defense equipment. The repeated attacks have forced Russian authorities to experiment with additional protective measures alongside traditional air defense. Beyond nets and cage structures, Russia has also attempted to deploy floating barriers to defend naval bases and maritime infrastructure. In the port of Novorossiysk on the Black Sea, large floating obstacles were installed to block the approach of Ukrainian sea drones. These barriers were intended to form a protective perimeter around ships and harbor facilities. However, reports from naval observers suggest that the barriers failed to fully prevent drone incursions and may even have limited the maneuverability of Russian vessels operating inside the harbor. Similar improvised barriers have appeared on land as well. In the Donetsk region, long lines of railway cars have been positioned along sections of the front in an attempt to create physical walls against artillery and drone attacks. The trains form extended barriers stretching more than 30 kilometers in some areas. Military observers say the intention was to create a shield that could obstruct incoming fire and provide cover for troop movements. However, analysts argue that the tactic also introduced logistical complications by restricting mobility and creating large stationary targets that could be easily identified from the air. These defensive experiments illustrate the scale of the challenge posed by modern drone warfare. Unmanned systems have become relatively inexpensive, widely available, and capable of striking targets hundreds of kilometers from the front line. As a result, both Russia and Ukraine have been forced to adapt their strategies rapidly. Russian forces have attempted to combine traditional air defense systems with improvised physical barriers and electronic warfare technologies designed to disrupt drone guidance systems. Electronic warfare has been one of the central pillars of Russia's response. Along the front lines, signal jamming equipment has been deployed to interfere with the radio communications used by many drones. These systems attempt to block control signals or mislead navigation systems so that drones lose contact with their operators. However, Ukrainian forces have increasingly introduced drones controlled by fiber optic cables rather than radio signals. Because these drones transmit commands through a physical cable rather than wireless communication, they are largely immune to electronic jamming. This development has reduced the effectiveness of many Russian electronic warfare systems that had previously been considered a key defense against drone operations. The combination of long-range strikes, drone swarms, and new control technologies has transformed the strategic environment of the conflict. Energy infrastructure, logistics hubs, and naval bases are now routinely exposed to attacks conducted by relatively small unmanned aircraft. As both sides search for effective countermeasures, the events in the Pskov region and along the Volga River demonstrate how difficult it has become to fully protect large industrial facilities in the era of drone warfare. While Russia has attempted to respond to the growing threat from drones with a range of defensive measures, Ukraine has been developing its own protective systems aimed at reducing vulnerability to similar attacks. Ukrainian military planners have focused on protecting logistics routes, transportation networks, and frontline troop movements, areas that have been heavily targeted by Russian drones throughout the conflict. One of the most visible solutions has been the construction of extensive anti-drone net systems stretched above roads used for military supply and civilian transport. Unlike the nets observed at Russian fuel facilities or on armored vehicles, Ukrainian net systems are deployed across large segments of roadway, rather than directly over individual pieces of equipment. Metal mesh structures are mounted on frames that extend across transport corridors, forming tunnel-like passages for vehicles traveling along key supply routes. The purpose of these installations is to intercept or disable small first-person view drones that approach at low altitude. When drones attempt to fly through these corridors to strike vehicles, their propellers can become entangled in the mesh, causing the aircraft to crash or detonate before reaching the intended target. Construction of these protective corridors accelerated during the early months of 2026. According to Ukrainian infrastructure officials, work crews were able to build approximately 5 kilometers of net-covered roadway per day in January. By February, construction speed increased to roughly 12 kilometers daily, and by March, it had reached about 20 kilometers per day. The Ukrainian government announced plans to extend these protective systems across as much as 4,000 kilometers of roads by the end of the year. An additional budget of approximately $37 million was allocated to support the project, with construction concentrated in several regions, including Zaporizhia, Kherson, Kharkiv, Sumy, and Chernihiv oblasts. Since the start of the program in 2025, more than 260 kilometers of roads had already been covered by protective nets. Military officials emphasize that these systems are not designed to stop heavy missiles or large strike drones. Instead, they focus on reducing the threat posed by smaller FPV drones that have become one of the most common weapons on the battlefield. These drones are frequently used to attack trucks, armored vehicles, and supply convoys moving near the front lines. By forcing drones to navigate through narrow, obstructed corridors, the net systems increase the chances that the aircraft will collide with the mesh before reaching their targets. Even when drones manage to pass through, the reduced maneuvering space and increased flight complexity can make precise strikes more difficult. Ukraine has also invested in defensive infrastructure beneath the surface. In several frontline regions, particularly in Zaporizhia and Donetsk, underground trench and tunnel networks have been expanded to protect personnel and equipment from artillery and airstrikes. Some of these systems incorporate Soviet-era shelters that have been modernized and integrated into larger defensive complexes. The networks include interconnected underground chambers linked by zigzag galleries designed to absorb blast waves and limit the impact of explosions. Many of these underground facilities contain supplies such as water, food storage, and communications equipment, allowing soldiers to remain protected during extended bombardments. These subterranean structures have been used as secondary defensive lines in areas such as Dnipropetrovsk and Zaporozhye regions. Military analysts say the tunnels complicate Russian advances by providing protected movement routes and fortified positions that are difficult to destroy with conventional artillery. By combining surface defenses with underground infrastructure, Ukrainian forces aim to maintain operational continuity even under sustained aerial attack. At the same time, Ukraine has continued experimenting with physical modifications to its own armored vehicles. Some Ukrainian tanks and armored vehicles have been equipped with cage-like structures similar to those seen on Russian equipment. However, Ukrainian engineers have attempted to refine the design by integrating the cages with electronic warfare components and mesh layers intended to interfere with incoming drones. These modifications, sometimes referred to as variations of a turtle tank concept, are reported to be installed on a large portion of main battle tanks and armored vehicles currently operating on the front. Additional defensive adaptations include the installation of metal spikes and wire structures on certain armored vehicles, a configuration sometimes described as hedgehog armor. These protruding elements are intended to physically disrupt drones attempting to land or detonate directly on the vehicle's surface. While such systems cannot guarantee protection, they are designed to increase the difficulty of achieving precise hits. Despite the use of both traditional and improvised methods, the conflict continues to demonstrate how rapidly warfare is evolving under the influence of drone technology. Russia has relied heavily on large-scale missile and drone attacks against Ukrainian energy infrastructure. According to an intelligence update published by the United Kingdom's Ministry of Defense on February 19, 2026, Russian forces launched more than 20,000 drones and over 300 missiles against Ukrainian energy targets during the winter period. These attacks aimed to damage electricity generation and heating systems across Ukraine. Ukrainian officials say the combination of protective road networks, underground shelters, and adapted armored vehicles has helped mitigate some of the damage from these strikes. At the same time, Ukrainian forces continue to carry out long-range drone operations against Russian facilities, including refineries and fuel depots that support military logistics. Analysts note that the ongoing exchange of attacks illustrates a broader shift in modern warfare, where relatively low-cost unmanned systems are capable of threatening critical infrastructure far behind the front lines. The events in regions such as Pskov and along the Volga River underscore the strategic importance of energy facilities in the conflict. Repeated strikes on refineries and storage depots have placed pressure on Russia's energy sector while highlighting vulnerabilities in defensive systems. At the same time, Ukraine's focus on protecting transport corridors and logistics routes reflects the growing recognition that supply networks are just as critical as frontline positions. As both sides continue to adapt their strategies, the war increasingly reflects a contest of technological innovation and rapid battlefield experimentation. Improvised defenses, electronic warfare systems, drone swarms, and underground fortifications have all become part of a complex and evolving military landscape. The outcome of these adaptations may play a significant role in shaping the future course of the conflict, as both countries seek ways to defend critical infrastructure while maintaining the ability to strike deep behind enemy lines. For continued coverage and analysis of developments in the war in Ukraine and other global security issues, subscribe to our channel and follow our updates.